Very good evening, good morning to all of you. Welcome you guys, welcome you all. Welcome you guys, welcome you all. How you are doing everybody? कैसे हो सभी लोग? All of you do join the session fastly. I think we are live. Yeah, check it now here. Is the audio video is clear to everybody? Audio video is clear to everybody. Tell me first of all. Is the audio video is clear to everybody? Do comment. Do comment. So audio video is clear to everyone. चलिए, so आज का सेशन हम शुरू करेगा. Let's start our discussions. And before this, you can have a look at another top educators of Unacademy. So here, there is a chance to get flat 60% of discount. आपको मिलने का chances है. And to get this opportunity, so you can use the code of B V Reddy. So, and you will get the personalized guidance from me and exclusive group for the students who has taken a subscription with this referral code of B V Reddy. Right. So you can plan your Unacademy subscription, but just for 2026 के लिए this is 10,999, 27 के लिए 17,999 only. And there are the new batches we are starting. You can have a look at now here from 7th onwards. We are started with the networks as well as the digital circuits. And to enroll for this, to join the Unacademy, you can use the code of B V Reddy. With this code of B V Reddy, you will get the great discount available. इसके साथ, so the personalized guidance from me and the DPP, शॉर्ट नोट्स, सब कुछ आपको मिलेगा. राइट. ये अदर 26 के लिए द बैचेस पर 27 के लिए भी हमने शुरू किया. ठीक है. एंड सम ऑफ द प्रॉब्लम्स वी हैव कंप्लीटेड यस्टरडे. आई थिंक यस्टरडे हमने इधर ये प्रॉब्लम पर कुछ गड़बड़ हो गया ना एक्चुअली इसमें. सो हियर द कनेक्शंस आर स्मॉल मॉडिफिकेशन इन दिस प्रॉब्लम. So here this arrow is like this. The arrow is like this. This is the problem. Arrow is, that means that T is equal to 0, switch is open. The switch is connected to the other part. Now ऐसा हुआ तो then we will please consider it as. Okay, then you can simplify it. Then you can simplify it. Done. So last class we did some problems. Now let's see the remaining problems. ये प्रॉब्लम भी हमने कंप्लीट किया ना. राइट. ये भी हमने कंप्लीट किया. Right. Yeah, now take this problem. Now take this problem. In the circuit, the switch SC is closed at T is equal to 0. Initial values of inductor current, capacitor voltage, both values are given as 0. In the steady state, they are asking the what will be the voltage across capacitor. Okay. Now you can see. Initial values are given as 0. Here we are applying the Laplace domain. We'll do it. So take the Laplace domain. Now T greater than 0, switch is closed. and here is a diode is placed. Now this inductor, whenever the inductor capacitor both has been connected, better you do for the Laplace only. There is no resistance is present. If the both inductors, capacitors, the two elements are present, go for the Laplace only. So here this voltage is how much you tell me now? 100. If you apply the S domain, so I can say this as 100 by S, and this is what we can say SL, and this is what element of 1 by SC. Now if I call this current, which will be equal to I of S, yeah, you can tell me now what will be the I of S here. It should be given as 100 by S by what I can say now here, SL plus 1 by SC. Now do simplify, take LCM and simplify this thing here. 100 by S by what I can say now here, S square into LC plus 1. So here by will come it as SC. So S will get cancelled. So finally हमको I of S मिलेगा. That will be equal to what you tell me now here, 100C by, in the denominator if I take LC common, so it will becomes LC common, then it is S square plus 1 by LC will come now. Now you can tell me now here. So where C will get cancelled. So what will be this I of S will come, you tell me? The I of S, which will come to be a what element now here? So 100 by L into what I can say now, this is S square plus 1 by, I can say this as root LC ka whole square. And this is in the form of, so here, yes, so that is S square A by S square plus L square. So then this will be given as what we can say now here. So Laplace domain will be converted now here. This is I of S inverse Laplace. And this, which I am writing it as 100 by L. Here we need to have 1 by root LC. Here we need to multiply with the root LC and divide with the root LC. So if we multiply with the root LC and divide with root LC, then it will come to be a what element of here, if the form of S square plus 1 by root LC ka whole square. So then I of S, it will come to be a what element of here, 100 by L into root LC. Okay, then this is of the form A by S square plus A square. The inverse Laplace, which will be equal to what we can say now here, sine of AT na, that is 1 by root LC into T. So then I of S, which will be equal to how much we can say now, 100 into square root of C by L. Square root of C by L into what element of here? So this is sine of 1 by root LC into T. So this is the I of T. So this is I of T. So that is a current passing through the circuit now here. Now they asking to find what you tell me now here, voltage. So how we can get the voltage from this current? What we can do here, voltage. So that is Vc of T. It should be equal to what we can say now here, that is 1 by C integral of I of T into dt na capacitor voltage. Now here you can see the limits we need to see here. So how this current you tell me now, I of T? So this current I of T, it should be a sinusoidal wave now, which is very sinusoidally. This is I of T. Now So this current, it should be very sinusoidally like this now. We have a sinusoidal current is passing. Now here it is a positive cycle and this is a negative cycle. So you see this thing, for this positive cycle, the diode is a forward bias. So then it will allow the flow of current. For the negative cycle, diode is a reverse bias. If it is a diode is a reverse bias, it does not allow the flow of current. So that's why there is a flow of current will takes place from up to here only now. So that means this is 0 and this value is what we can say now here, that is pi into root LC. So that is 0 into what I can say here, pi into root LC mein hoga na. Up to that only there is a flow of current. So from this we can say now V of t. That is Vc of t. It should come to be a what, tell me now here, 1 by c integral 0 to pi into root LC by I of t. I of t is how much here? 100 into square root of c by L into what element of sine of t by root LC hoga na. Now tell me the integration of this function. अगर हमने इसको इंटीग्रेशन किया तो so what I will get now, Vc of t, you tell me now here. So constant we can take out bahar outside. So this is 100 by root LC. Integration of sine, which is a minus cos of what element of t by root LC by what we can say now here, 1 by root LC. And the limits are what to tell me now, 0 to pi into root LC होगा ना. अभी क्या होगा, you tell me now here. In this root LC will get cancelled. Now अभी हमको क्या मिलेगा, you can see now limits, substitute the limits. So then Vc of t, it will come to be a what, tell me now here. So this is minus 100 into, when I substitute the upper limit, so it will becomes what element of t value this much. So it is cos pi banega minus this is what element of cos 0 banega. Cos pi value how much? Cos pi value minus 1. So this is minus 100 into minus 1 minus 1. So finally what is the Vc of t, you tell me, and which is equal to 200. So that means how much is voltage, you tell me now, 200. This is one of the very important problem, बहुत बढ़िया problem भी. So here this is why the limits we have taken 0 to pi into root LC, that is because of what? Diode. Here the diode is there now, because in the diode forward bias only it will allow the flow of current. Reverse bias it does not allow the flow of current, right? इसलिए done. And चलो next one. And take the next one. Given V2 of 0 given as a 10, Vg of 0 given 0, what is the voltage across the capacitors in steady state? In steady state, they are asking the values. Yes, which is closed at t equal to 0, which is closed. Now here also we can do S domain. Right, now you can redraw the circuit now here. And Vg does not have any initial value, but V2 has initial value, right? Yes, which is closed at t greater than 0. And here we have a resistance is there. So you can have a look at now, this is how much the resistance is given as a 1 mega. So this is 1 mega given, and here this capacitance converting into, yes, let us say 1 by 8. This is micro. Right here, this initial value given are 10, so this is 10 by S, and this is 1 by 2S. Okay. Now again here we can find the current through the circuit now in S domain. Thereafter we can find the inverse Laplace. Yeah, you tell me now here how much this I of S. It should be given as what element of 10 by S by 1 by 2S plus 1 by 8S and plus here this is 1. So this value I am simply making it as, let us say this is R equal to 1 mega. Right. Now simplify now LCM ले लिया तो, so then this value, so this is 10 by S and the LCM which I can say this is 8S. So then this is what element of 4 plus 1 plus what element of here 8 RS. Now you can tell me now what will be this I of S, and that will S will get cancelled, so then it is 80 by, so you can tell me now here 8RS plus 4 plus 1 5. अगर 5 common ले लिया तो then it will becomes what element of 16 by, so this is 16 RS plus 1, then it is what I can say now 16, we have taken 16 R common, then it will becomes what element of here S plus 1 by R. Okay, then 16 will get cancelled, 1 by 16 also, no? 1 by 16 also. R equal to 1 we can place it. R equal to 1 will place it. Right, so then, so this will be 1 by, what will come here? So we have taken 16R, this is R into what will come here? S plus 1 by 16R will come now. Okay, here, what is this thing here? 8. So this is what to tell me now here? 8 by, so we are taking 8R equal to 1. 8R we have taken common, then it is S plus what we can say now here? 5 by 8R. So then I of S will come to be a what element of here? This is 1 by R into 1 by S plus, that is 5 by 8R. So R equal to 1, so that is I of S, which will be equal to 1 by S plus 5 by 8. Now this is I of S will come now, you see. Then simplify it now here. So what I need to find now here? The voltage across capacitors in steady state. In steady state capacitor voltage chahiye. So from this, if you, this is I of S, same kind will pass na. Same kind will flow to the both the capacitors. So now if I want this voltage across this capacitor, it should be given as what? Tell me now. Yahan tak everybody done it na? Everybody got the same thing. 10 na here. Okay. Got it, all of you, same thing. Rs by 5. Why it is here? I have taken 8R, we have taken common. 8R we have taken common. 5 by 8. 8R will come. So then now I need this voltage now here. So here what is let us say this is V2 of S. If I say that means this voltage, it should be given as what we can write. You tell me now here. This is 1 by 2S into I of S. I of S is 10 by S plus 5 by 8. Okay. Now we need I2 V2 of infinity. So we can apply the final value theorem. So this is V2 of infinity, which is equal to what I can say now, limit S tends to 0, S into V2 of S I can say now. Then it will come to be a limit S tends to 0. This is S into what I'll now 1 by 2S. That is 10 by S plus 5 by 8. इसको simplify करो. So then S will get cancelled. So then 2, this is 5 now here. S value 0 will come to be 8 now here. It will come to be 8. And thereafter, and we can see the Vg. What about the Vg value? Vg of S. Vg of S, which will be equal to how much, you tell me? So I of S. So this is 1 by 8S into what, tell me now? V I of S. I of S. Same thing here also we can apply final value theorem. That is Vg of infinity, which is equal to what I can say now here. Limit S tends to 0, S into Vg of S. Now tell me now Vg of infinity, which is equal to limit S tends to 0. This is S into, this is 10 by, no, this is S into what tell me now 1 by 8S into what tell me now here 10 by S plus 5 by 8. Now simplify karo this one, cancellations, and S will get cancelled. So then 0, when S is equal to 0, it will come to be what, tell me now here. So this is 10 by 8 into 5 by 8. Now this 8. So this value 2 will come. So this value 2. So constant option you can see now, option B. Got it? So this Laplace domain problems are very, very important. In this session, our complete focus is on the Laplace domain problems. Next one. V of 0 plus and VC 1 of infinity in the figure shown. V of 0 plus. That is inductor voltage and VC1. Where is the VC1? Here. This is the VC1. Now let's see the things now. Transient values case, we need to find the past behavior t equal to 0 minus values first of all. T equal to 0 minus, what happens to switch, you tell me now here. Yes, switch is closed like this now. T is equal to 0 minus, which is opened. At T is equal to 0 minus, which is open. The switch is open, the initial values, all values are zeros only. There is no values now here. I can write it as, what tell me now here? IL of 0 minus, which is equal to 0. Next, VC1 of 0 minus, which is also 0. And VC2 of 0 minus, which is also equal to 0. Right. Next, अभी हमको क्या चाहिए for t equal to 0 plus values. Yes, now t equal to 0 plus, if I see transient state, yeah, in transient state, let's redraw the circuit. Now switch is closed, right, switch is closed. Now you can see now capacitor is short circuited, C1, C2 both are shorted. And inductor is open circuited with the initial values, but there is no initial current, so inductor completely open circuited like this. And this is the circuit at t equal to 0 plus. Now this is V, this is R2 and this is R1, and this voltage, which I can say this as V of 0 plus. V of 0 plus. Tell me how much this value you can see now. So you can see now this is the short path is there. So that's why there is no flow of current. There is no flow of current through in this resistance. This current through in this branch is 0, and then thereafter, so will go, current will flow इस path में जाएगा like this. So then how much this V value you can see now here, that is VA of 0 plus. VA of 0 plus, it should be equal to what you tell me now here. So then this value, how much will come it as? So complete kind. So this the dead element banega na. So directly this voltage only, V only. Next, what else we need to get now here? VC1 of infinity, that is a steady state. Yes, now for as t tending to infinity in steady state, and how this capacitor C1, C2s are open circuited, and how about the switch you tell me? And switches are open. Switch is closed now here. C1, C2s are open circuited, and inductor is shorted like this. Inductor is shorted. Now this, now this is V. Yeah, we need this voltage required now. This voltage is what we can say now, VC1. So that is VC1 of infinity, and this is R1 and this is R2. Yeah, you can see now here where this current will flow. So you can see now here. So now if we can apply KVL in this loop now here, that is VC1 of infinity, and which is also equal to V only now. Right, so that means what's the option you can see? Option A. Next one. Now see the next one. When a constant voltage source V is connected to a series RL circuit with zero initially stored energy in the inductor, the instantaneous value of power supplied to inductor is given by. What is the instantaneous values of power supplied to the inductor? We'll try it 1 minute. right? When a constant voltage source V is connected to a series RL circuit with a zero initially stored values. Okay, energy, initial energy 0. Now they ask him the instantaneous power they ask him to find. Yes, now that means initially value is 0. Yes, Vc of 0 minus, which is equal to 0. Yes, Vc of infinity, it will come to be a V na. Yes, RL circuit na here, this one. Okay, so this is, yeah, here, sorry, this is RL circuit now. I thought it is RC. Right. Now you tell me now what is this thing here? IL of 0 minus, which is equal to 0, and IL of infinity, which is equal to what you tell me now? V by R. So from this we can get this relation now here. What is IL of t? You tell me now here. So this is final value plus initial minus final into e power minus t by tau, that is V by R into e power minus of t by tau. Tau is equal to what? Tell me now. L by R. This will becomes what? Tell me now here. R by L into t. Yeah, this is the current. So from this we can get this voltage now. What is VL of t? And V equal to L into di by dt. V equal to L into di by dt. So you can see now here VL of t, which is equal to L into di by dt, that is what element of minus V by R into what element of minus R by L into e power minus of what I can say R by L into t. So then VL of t, which will be equal to will come it as V into e power minus of what element R by L into t. This is the voltage and this is the current. They are asking to find what element of instantaneous power across the inductor. They are asking a instantaneous power. So you can tell me the instantaneous power, the which is given as what I can say now P of t, which will be equal to VL of t into IL of t, instantaneous power. So if you multiply these two here, what will come here? V, I can say this as V square by R. V square by R into e power minus of what element R by L into t minus V square by R into e power minus of 2R by L into t. वो यहाँ आएगा चेक करके बोल. Yes, so here, so the instantaneous power, it should be given as what? V square by R. So that is e power minus of what element of R by L into t minus e power minus of 2R by L into t. So कौन option you can see? Option A. Next one. The switch was closed for a long time before opening at t equal to 0. The voltage Vs at t is equal to 0 plus. The switch was closed for a long time. That is initially at t is equal to 0 minus, that is closed. Now here inductor reaches to steady state. So you tell me now what is the current through the inductor, you tell me. In the WhatsApp group you will get. The WhatsApp group you will get. So that is at t equal to 0 minus. In the WhatsApp group, this complete PDF I will share. At t equal to 0 minus, switch has been closed. Now find this current passing through the inductor. Yes, switch is closed. Here is a resistance. And how the inductor will behave, you tell me. Inductor is shorted. Now this current is at 2.5 amps, and here this is at 20, and here this is a 5. Right here this current is what we can say, tell me now, IL of 0 minus. So how much this IL of 0 minus, you tell me. That should be equal to complete current will pass us the inductor only, 2.5 amps. Next. So now consider circuit at t equal to 0 plus. At t equal to 0 plus. Now tell me now here, switch is open, then there is no effect of source now here. So inductor will start discharging via resistance. Right, so here inductor, it will behave like a open circuit and it has some initial current. How much that initial current you can see now? The initial current is there. The initial current we got it as 2.5, and this is, sorry, this is 20 now. Right, so here, and this is 20 ohms, and here this current is 2.5. Right, we need now here this voltage we require. This is what we can say now here, Vx of 0 plus. Here you can tell me now what is the Vx of 0 plus. Now this current will enter here now, so this is Vx of 0 plus. It should be equal to what we can say, that is 20 into 2.5 plus or minus, you tell me, which will be equal to 50. Plus 50 or minus 50, you tell me. Plus 50. Okay. It was mistaken now, so that's why I confused here. Okay, this is a 20, typing mistake. This is 5H. Okay. Yeah, next one. In the circuit shown, C1, C2 given as a 2 farads, and the capacitor C1 has a voltage of 20 initially. And when S is open, the switch S is closed. Okay. With the switch S is closed at t is equal to 0, the voltage Vc2 is. Right. So they given initial values, they has been given when C1's, when the switch is open. And they are asking what will be the Vc2 after closing the switch. Right. So you can see now here, let's apply the Laplace domain, that is for t greater than 0. T greater than 0. So let's draw the circuit now here and convert into S domain. And here is an inductor. And the capacitor C1 has initial value given now how much? 20 given. C1 initial voltage which is given as 20, and the C2 does not have any charge, and switch is closed for t greater than 0, and here this is C2, and so we can say this as SL, and this is 1 by so 2 given 1 by 2s C1 C2 sir, this is also 1 by 2s, and the capacitance value how much you tell me now, 20 by s. Okay, now tell me now this current, if I call this as I of s, yeah, what will be this I of s, you tell me? So that should be given as what we can say now here, 20 by s by what I can say now here, 20 by s plus 1 by 2s plus 1 by 2s plus SL. Yes. Instead of that, directly we can apply voltage division. Instead of finding this current and all, so directly we can apply voltage division, that is Achayana. Now we need what element of here, voltage across which capacitor, C2 required. So it means this voltage required now, that is VC2. Here tell me now VC2 of S, which will be a 1 by 2s. This is 1 by 2s by, tell me now here, 1 by 2s plus 1 by 2s, inductance value not given now. Yes, that is SL, okay, into 20 by s. Okay, then simplify it. Now what will be this thing here? This is 1 by 2s by, yeah, 2s is the LCM, this is 1 plus 1 plus, yeah, 2s so square L by 2s into 20 by s, and 2s will get cancelled. Then what will get, you see, so that is VC2 of s, it will come to be a 20 by s by what element of here, 2s s square. So this, if I take the 2l common, then it is s square plus 1 banega na, check karo. Then it is s square plus 1 hoga na, tell me. Okay, so then this value which will come to be a, so 20, so it is 10 by L, okay, into what I can say now, s by s square plus 1. So this is, from this if I take the inverse Laplace Vc of t, it will come to be a 10 by L into s. Now this is of the from inverse Laplace, which will be equal to cos now here, cos at now here, s square plus a square. So then inverse Laplace. So that means from this what I can say now, this is nothing but what type of voltage, you tell me now, sinusoidal voltage. Then we are getting it as what, tell me, sinusoidal voltage will come. Sine wave means, sinusoidal means what, either sine or cos to will be called as sinusoidal only. Okay. Next one. In the network shown, the switch is open at t is equal to 0. Prior to that, network was in steady state. Find V at t is equal to 0 plus. Yes, now find the values now here, t is equal to 0 minus first. Now tell me now t equal to 0 minus. right? When t is equal to 0 minus, so the switch is opened or closed. So switch is closed, isn't it? When the switch is closed, from this we can able to get the initial values. Now tell me now. So then the complete, so we can write it as VC. VC of 0 minus, which is equal to 0. And what about this is IL of 0 minus, you tell me now here, which is equal to 10 by 10, 1 ampere. Check karo. Now we need a t is equal to 0 plus, right? Tell me now, t is equal to 0 plus means t equal to 0 plus, that t is nothing but transient state now. Yes, in transient state, how the inductor will behave, you tell me. Inductor is open circuited and capacitor is short circuited. Now let's redraw the circuit now here, t equal to 0 minus. So 0 plus, if you redraw the circuit now here, then it will come to be a. So here the resistance capacitor is shorted and the switch is opened. Now the switch is open now. That means we need the voltage across that 5 ohm resistor is chahiye. So this inductor is open circuit with the initial value of current is what, tell me, 1 ampere. This is 10 and we need this voltage. This is what, tell me now, V of 0 plus. How much this value? 5, and this is what, tell me now, 10 volts. Yeah, what is the V of 0 plus, you tell me? It should be equal to 5 volts. Done. Next one. Assume that the circuit shown in the figure is reached steady state. Excuse me. Before t is equal to 0. When the resistance 3 ohm suddenly burns out, resulting in an open circuit, then they're asking to find the current at t is equal to 0 plus. Yes, good problem. Yeah, you can try it now. First, initial values, you will find the voltage across capacitors, two capacitors. Now, if I call this as V1, let us say this is V2. And find the voltages across both the capacitance now before it burns out. Right. Now here, how these capacitors will be C1, V1, these two capacitors are in steady state. Right. Those are in steady state. In steady state, those will behave like a open circuited. So then in that scenario, what about the, so here this is, those will becomes steady state now open circuit. But there is no bridge, but there is no use of the bridge concept here. Now how these capacitors you see? If you draw this bridge, right now here they given this as a 2 ohm and this given as a 3 ohms is given, right? So the two capacitors, it has placed like this. Now how much this voltage? Now 12 volts, and this is 1, right? So this is the scenario. If we can call this as V1 of 0 minus, and this is what will be now V2 of 0 minus. Yeah, here there is a resistance is there. Now how much this resistance is at 2, right? Yes. Here you can see now there will be a flow. So here initially this current, how the current will flow, you can see now here. Yeah, the current will come like this. Current will flow like this only. There is no effect of this resistance at all. So then equivalent resistance of the circuit, you tell me now here how much this value. So series now here 6. That is 6 ohms. So that means this initially current which is equal to 2 amps. And here this current is 2 amps. So this current is also 2 amps. Here this current to 0 aina. Right, so then we can say it as V1 of 0 minus, which is equal to how much? 4, and then V2 of 0 minus, which is equal to what? I'll know 6 volts. Okay, now this is the initial values. Now that is, now let's talk about t equal to 0 plus. What's happened now? T is equal to 0 plus, this 3 ohm resistance is burns out. Now you tell me now what happens in that scenario. Here is a resistance of, this is 1 ohm. Now here this is the capacitor. Now this is the open circuit, right? Right. So here this is the capacitor is shorted with the initial voltage now here. And how much is initial voltage? Here this voltage is how much? 4 volts. And this capacitor is also shorted with the initial voltage. How much is voltage? You tell me now here? 6 volts. Now this is 2, and this is another 2, and this is 1, and this is 12. Done. Now you tell me now. We need the current through this resistor wheel. They didn't give the direction. Simply we'll find the magnitude, we'll find. Yeah, tell me now here. So this is 6 volts. If this is 6 volts, now the current here has to go in this path. Now here 4, and at this location I can say this voltage is 10 volts. 6 and 4, 10 volts. Now if I find this current now here, 12 minus 10 by 2, so this current is 1 ampere, so 2 amps now. So 12 minus 10, that is 2 amps. Now you see this thing, this current up to here, this current is now 2 amperes will come. Now you can see the scenario now here. So in this loop, if I see this thing here, how much this current will flow, you tell me? 1 ampere. In this one, here there is a flow of current as what? Tell me now here? 1 ampere will flows. 1 ampere. And they same this 1 ampere will flows here now. Yes. How much this value will flow, you tell me now here? 1 ampere will flow. This is 1 ampere. They are asking the current through this resistor only now 2. How much this value, tell me now? This is 1 ampere. Here this current is 2 amps, but here this is 1 ampere only. Hmm? 1 ampere, 2 amperes, but here we are getting 2 amperes. We are getting now. Now, So here in this branch may tell me the equivalent value here. How much is resistance here? 2. This is 2. If this branch, these two resistors are series. Okay, these two resistors are series. Yeah, so that means इसमें करंट कितना जाएगा? 1 ampere will go ना. Either 1 ampere will come. Yes. Now this is 1 ampere here. 1 ampere and this is 1 amp. No, this is 1 plus 1, 2 amperes बनेगा इधर. Yes, check it now here. कोई गलत तो नहीं किया ना हमने. So this branch you can see now 4 2 2 it will be equally. So we have the voltage 2 2 will divide. So the current is 1 ampere there. Here also 1 ampere. This is 1 ampere. Here also we have 1 ampere. Okay. If I let me draw this part again, it's creating little confusion. Right, so it is behave like a voltage source now, and here is a resistance of 2. Here also we have a resistance of 2 is present, and then this is another voltage like this. ऐसा circuit बनेगा. Right, how much this value? Tell me now. 12, and this is 1. Right, so this is 2, this also 2, this is 4 volts, and this is 6 volts. Right now? Yeah, you can tell me now here. Here is a ground, so that means this voltage we can say this as 10 volts. So then how much this current you tell me now? 12 minus 10 by 1, so this current is 2 amps. Okay, so this current, so the entry current here which is equal to 2 amps will come. Yes, this current which is coming here, it is a 2 amps is coming. Now yes, in this loop mein we have this current. So in this loop we have this current. It should be equal to how much you tell me now here. This current is 1 ampere. Yeah, this current is another 1 ampere, and this current is 1 ampere. So we need in this branch mein current chahiye na, so that is 1 ampere only. Check karo. That is 1 ampere. Done. 6 volts is 2 amperes. Yeah. 1 1, then this is 2 amperes. Yes. Okay, fine. Okay then. That's it. So these for this today's sessions, and the next session will meet the next problems. Next class we'll do AC circuits will do. Next class we'll do problems on AC circuits. Okay. Okay then, see you. Bye-bye.